Final topics. These are actually, I think, my favorites. I've done quite a lot playing around with these over the years. But anyway, we took cobalt and then copper, and we added some hydrochloric acid and saw what happened, and then we added some water. So let's look at those, starting off with the cobalt. So take cobalt 2+ in water. It is a pink solution. Add HCl to it, and it goes blue. Right now, I added quite a bit of HCl to it to get this blue. As it was going to the blue, it went through a purple stage, and of course blue mixed with pink is kind of purple. Then I took that solution and I added more water to it, and what happened was that it started turning back to pink. Again, I've caught this as I've added enough water to turn the top half pink. We haven't quite got yet to the bottom half. Okay, now that is happening because of a really nice equilibrium between the octahedral cobalt 2+ that has 6 waters coordinated to it, and the tetrahedral blue cobalt tetrachloride dianion. Okay, octahedral cobalt with water pink, tetrahedral cobalt with chlorides blue. So if I take my solution here, that's mostly the octahedral cobalt with waters, and I add in some HCl, well then I'm adding in some reactants, and any time that you have an equilibrium and you add in reactants, it pushes the reaction to the right. And so adding in these chlorides pushes the reaction to the right, thereby making the blue tetrahedral cobalt. However, now I take this new equilibrium that's over on this side and I add water. Well, here I'm adding something on the right. I'm adding a product. What does that do to the equilibrium? It pushes it back to the left, so the blue goes to the pink. So a really lovely equilibrium, lovely illustration of Le Chatelier's principle. And so there we are, writing it all out. And another lovely, very similar example is with copper. So we take copper 2+ in water, it's that pale blue, we add HCl to it, and it goes, well, I've said yellow, sort of looks green. This is a yellow, but of course yellow with blue looks green. But then if I add back in some water into this, there's some of that residual yellow-green, and hopefully you can see that this top part is gone back to blue. And it's exactly the same concept. We have the octahedral copper with waters there, that's blue. We have a tetrahedral copper with chlorides, is yellow, and the equilibrium, we take the blue, we add chloride to it, and that pushes the equilibrium to the right. As it pushes the equilibrium to the right, we're pushing it towards the yellow color, but when we add water to it, that's going to shift the equilibrium back to the left, push it back towards the light blue color. Hopefully these videos explaining what you saw or what you should have seen with the inorganic part have helped. Goodbye.